Greetings to the participants of the Analog Astro Conference 2025. My name is Boris Petrovic. I represent the Astronaut. Congratulations for the successful 100 analog mission at the Analog Astronaut Training Center in Poland. Astronaut Space is an American company based in Austin, Texas. The focus is on space agriculture and space biotechnology. We house a small laboratory in Belgrade, Serbia, where we work with research and development of hardware and software to enable plant-based space agriculture systems. We also have a second focus on space biotechnology. Our method involves vegan diets. We believe that the most efficient method to feed the future space settlers would be plant-based. In this sense, we developed a number of hardware systems that are somewhat automated. Basically, these are lightweight, movable hydroponic systems and hydroponic rack systems that can be used in analog astronaut missions and training, and also for analog astronaut centers for further research in space agriculture. Currently, we're also working on the development of a number of photobioreactors. We did research with the algae culture of spirulina, and we developed small inoculation systems, also personal photobioreactors that can be used in kitchens of the personal bioreactors are intended for experiences with our Astronaut app. So we aim to provide a selling mechanism, and we would ship these personal photobioreactors to any person that is interested in space agriculture. These are automated systems controllable by a cell phone using Bluetooth. They have an air pump that provides necessary gases to the algae vessel, which is a 1.5 liter volume of water with the nutrients for algae. We work with the Zaruk medium for algae culture growth. Adding to this, we developed a larger biomass photobioreactor that consists of three cylindrical glass vessels, each of 10 liters. So the total capacity of this research bioreactor would be 30 liters. This specific device has an automation system, like an embedded controller that deals with the air pump in a timed timeline, programmable. It also has a pH sensor that records the state of the pH in one currently of the tubings of the research bioreactor. The sizes of these racks are from 160 centimeters of height, with 70 centimeters of width and 40 centimeters of depth. And we have developed a number of protocols that are coming out from the vegan diet. We co-founders of Astronaut are vegans for many years. It is a sustainable lifestyle that we aim to bring into the future space exploration movement. We worked with a number of plant-based meals. Basically, these are vegan recipes. Out of this, we developed a Vegan Out app, which is an application, a web kind of service, and that we intend to use with the Vegan Out space analog astronaut missions. So we aim to provide training, space agriculture training, using the plant-based method. That means exclusively feeding the analog astronauts with the produce that is created from the hardware, the Vegan Out racks, the hydroponic racks. And also we aim in the future to research the possibilities of using the algae and also the plant-based racks for environmental control and life systems within a more advanced and high fidelity analog stations. In this sense, we invite potential partners that are analog astronaut training centers to jointly develop plant-based missions with a focus on space agriculture, space biotechnology, and also astrobiology. We have developed protocol for the mission, and we also invite potential analog astronauts that are willing to join this movement and experiment with the plant-based diets. With the development of the Vegan Out app, we aim to promote the plant-based space exploration method with various types of challenges. First would be a kind of a lunar 7-day challenge where people would immerse themselves into the basics of the plant-based diet. In this sense, they would not necessarily need to produce their own foods, but they will adapt first to the diet. And then a more difficult challenge would be the 30-day Mars challenge, where we would simulate even in homes. People who are interested in space exploration can do this from their home using the Vegan Out app. But on the missions, we would aim to provide most, if in the future not all, the food from the space agriculture racks. Vegan Out has worked on publications, scientific publications. One is a recently published paper at the International Astronautical Congress of 2025 in Sydney, which I think is 15 pages or so, and with good references, describes one of the processes of the hydroponic plantation, duration, the process from the plant nursery to the hydroponic system, how much time does it take for a plant to grow, what weight of the biomass is produced, and what automation system is involved, what type of water usage and light usage we're using with the hydroponic system. So this publication, we focus mostly on the hydroponic system. Then we had a poster session at the Melissa conference in Spain. Melissa conference is the European Space Agency supported conference of environmental control and life support system, where we also gave a summary on the details of the usage of the hydroponic system. Furthermore, we published a 25-page paper at the annual Interstellar Research Group Symposium held also in Austin, Texas this year, which covers a simulation of a generational ship. As such, we describe the use of the Veganout plant-based method to feed the future nearby star settlers. In this case, the Starship could only provide food from the plantation in low Earth orbit. We can rely on resupply missions on the Moon as well. On Mars it will be more difficult, so the space settlers on Mars would need to plant their own food, but on potential larger fusion propulsion starships, the future space explorers would need to rely mostly on planted food. And in this sense, we demonstrate a huge efficiency of the plant-based method. We understand that the method is more efficient than any kind of livestock producing method because of the specificity of the life support systems. The plant-based method is positive in the sense that it provides oxygen and it takes the carbon dioxide from the atmosphere of the ship, and any livestock feed would significantly increase the amount of water and power needed. We're working on the development of artificial intelligence. That's from the simulations and the application and the synthetic data providing and the research-based data that we have for specific plant species, but this is work in progress. We developed an AI character named Vega, and she's basically a large language model that understands somewhat that she is in a type of an analog astronaut mission. We are working on fine-tuning these large language models for specific scenarios of missions according to some research aspects, and we invite potential partners and co-authors for further publications in this sense as well. Thank you very much for inviting us to present at the Analog Astronaut Conference in Poland in 2025.